Assalamualaikum warahmatullahi wabarakatuh. My name is Indonesia Binti Abu Bakar and my metric number is C10222. I will answer question for 2.1, which is in the question we need to tabulate the value for our experiment. So for this experiment, we use the start time is 2, initial value is 2000, final value is 5000 and the sample time is 0. For this value, it will affect to our graph on our experiment later. So that's all from me and thank you.
Hi, my name is Rosie. My matrix number is CE19023. I will explain for the question 2.2, which is about P controller. So here, the second are the model for P controller, where I will exchange the value in here. So when the value of P, which is proportional, is to 1, the result that appear is this. Then when I change the value to 0.1, okay, wait. This is the waveform that appear. And lastly, when the value is 0.15, so this is the result waveform that I get. Here we can see the value of overshoot, rise time, and etc. Okay, I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Iqbal bin Muhammad Atifi. My metric number is CE200113. I will discuss about question 2.3. Question 2.3, he's asked to repeat the 2.1 experiment using PID controller, and I use for P equal to 1 and integral equal to 1. So here is the result for P1 and I1. The steady state response error is 1.26. Rush time is 0.696, and settling time is 0.104, and maximum overshoot for P1 and I1 is 630.7. Next, I will test for pi P equal to 1 and I equal to 0.01. And here is the result for the pi 1 and I 0.01. So the steady state response error is 1.68%. Rise time is 0.692 second from 10% to 90%. Settling time is 0.104 second, and maximum overshoot for this graph is 5084. Next, I will for test 3, I will use P equal to 0.1 and I equal to 1. So here is the result for P1 and P0.1 and I equal to 1. You can see for this graph, it reached the steady state at 7.960 seconds, and the steady state response error is 0. The rise time for this graph is 0.893 seconds from 10% to 90%. Settling time is 0.206 seconds, and maximum overshoot for this graph is 8,611. That's all from me. Thank you.
Assalamualaikum, my name is Muhammad Arif Ahmad and my metric number is CE200115. Okay, for this exercise, I will discuss about 2.4, which is we repeat the 2.1 experiment but using a PD controller. Okay, for the first trial of PD controller, I set the value of P is equal to 0.25 and then I set the value of D is equal to 0.1. Okay. Here is my block diagram circuit with a PD controller. Okay, for the first trial, here is the output graph for the first trial, which is P equal to 0.25 and D equal to 0.1. Okay, during the first trial, we observe that there are disturbance appears on the steady state error. Then we try a second trial but using different parameters of P and D. Okay, for the second trial, we using the value of P is equal to 0.25 and then the value of D is equal to 0.0025, and the output that we obtain from the second trial is like this. Okay, here is the diagram for the rise time, and here is the output block diagram for the steady state error for the value P equal to 0.25 and D equal to 0.0025. Okay, from this output, we can use the cursor measurement to find the value of rise time, which is equal to 1.147 second, and we also can find the steady state error, which is equal to 1.78%, by using the steady state error formula.
Assalamualaikum warahmatullahi wabarakatuh. My name is Indonesia binti Abu Bakar and my metric number is CE100222. I will answer question 2.5. In this question, I use PID controller and I will insert the value of the P, I and D. Here, I have insert for the proportional value is 1, integral value is 1, and also derivative value is 1. And now we click OK, and then we run. Then the waveform will appear like this. So in this area, then we have the value of overshoot, rise time, and others. Next, I will insert the other value for P, I, and D. So here I have insert for the value of P is 0.1 and value of I and D I insert 0.01. So we run the program and then the output. Here we can see the steady state error is 500 and the overshoot is 0.505% and the rise time is 11.102 seconds. Next, I put the value for PID is for P value is still same is 0.1, but the value for integral and derivative I changed to 0.001. So we run the program and the output will appear like this. There is some overshoot here, but here is the step response, which is 4,950. So here we know the rise time and the for this graph. So that's all from me and thank you.
Okay, for the 2.6, we need to summarize all the result in the table. Okay, in the table, we have the settling time, we have the response times, maximum overshoot, and steady state response. Okay, as you can see here is the data that I get from my friends and we conclude in one table.